Chapter 3, Lesson 3 is on the angles of polygons. Previously, we discussed the interior angles and exterior angles formed by triangles, and now we're going to expand the interior angle idea to talking about any polygon, meaning not just three sides, but four sides or six sides or greater. Let's first start with vocabulary. A blank is a closed plane figure made up of three or more line segments that intersect only at their endpoints. That definition is the definition of a polygon, a word that means many sides, and it's saying that a polygon is made up of line segments and they only intersect at their endpoints. So the line segments, that tells me it cannot be any shape with rounded or circular sides, which is why this shape's not a polygon and this shape is not a polygon. Also, it can only have the segments intersecting at their endpoints. And if you look, say for instance here, there's an intersection here on the line segment, but it also intersects here and here. So it's intersecting at more than just the end point. So not a polygon. In fact, let's label that not polygons. On the left, those are all examples of polygons. Now that we know what a polygon is, let's look at how do we figure out the total of the angle measures inside. In our previous lesson, we learned how the angles of a triangle add up to 180 degrees, and that helped us find missing measurements. If I want to find the missing measurements of a six-sided figure, I need to know what do the angles of a six-sided figure add up to. And there is an equation for that. The equation goes S, which is for sum, the sum of interior angles is equal to 180 degrees times, and we say n minus 2. N is the number of sides. We're going to use that equation to find what the sum is for some polygons, and then I'll show you how we use it to find the missing angle inside of a polygon. Example 1. Finding the sum of interior angle measures. Find the sum of the interior angle measures of the school crossing sign. We need to first know what is the number of sides of the school crossing sign. This is an example of a pentagon or a five-sided shape. So n equals 5, and I can now use the equation to find what the sum is. Here's our equation, but instead of n, I'm going to substitute in the 5, and we can go ahead and find the sum. Order of operations tells me I need to go ahead and do 5 minus 2 first. So I get 180 times 3. And we'll do that off to the side real quick. 3 times 0 is 0. 3 times 8 is 24. 3 times 1 is 3. Plus 2 is 5. So I find that this is a total of 540 degrees. And that is our sum. The equation will not change. All you have to do is know the number of sides, and then you can fill it in and then evaluate. I want you to try that now. Let's go down to the 2 try it questions. You'll pause the video and find the sum of their interior angles. Then start the video to check your understanding. Pause now. For 1, there's 1, 2, 3, 4, 5, 6, 7. So for the sum, it's 180 times 7 minus 2. So 180 times 5. And let's see. I find that the sum is 900 degrees. For the second example, we have a honeycomb, and the honeycomb has 6 sides, so we can find its sum. So 180 times 4, and we'll do the math real quick. We get a total of 720 degrees. The reason why we find the sum is it will now allow us to go and find missing pieces of polygons. The idea is it gives us the tool to find pieces that are missing. Let's now transition and talk about finding one interior angle for any size polygon. We have this green polygon and it says find an interior angle measure of a polygon. So one of our angles is X. And this shape has 1, 2, 3, 4, 5, 6, 7 sides. So in order for us to find this, we first need to find the sum. So we'll use the equation that the sum is equal to 180 times 7 minus 2. Simplify, it becomes 180 times 5. We find 900. And now we can go on to the second step. The second step is now how do we use this to find the single angle inside? We could make an equation. We could add up all the angles on the inside. So could say x plus 128 plus 130 plus 120 plus 115 plus 145 plus 140, and those together equal the 900 we just found. Now we need to add all that up. So let's take a moment, add up all the like terms, all those other angles. So I'm adding them up on my calculator right now. And I find that these 6 angles that I do know all add up to 778. I still have my x equals 900. And to finish it, to solve for x, we'll subtract 778 from both sides of the equation. X is equal to 122 degrees. And that is my missing angle. It takes 2 steps to do this. And no matter what, you do have to know the sum first. Once you have the sum, you have to be able to combine your like terms and solve for x. With this as an example, there are two try it questions. So let's move down and take a look at those try it questions. Pause the video and come back to check your understanding. Let's find x. First, we find the sum. So that's 180 times, let's see, 1, 2, 3, 4, 5. So 6 sides. So 6 minus 2. That's 180 times 4. We did this one earlier, but that's on the other part of the notes. It equals 720. So that's what they all add up to. So now I do my second part where I add up everything. So x plus 125 plus 120 plus 125 plus 110 plus 135 equals 720. I got to add up the angles I know so I can find the angle I don't know. When I added it up, I got 615. I'll bring down my x, bring down my equals 720, leaving me with one last step. Subtract 615, subtract 615. So my missing angle is 105 degrees. For the next one, first the sum. This is a four-sided shape, so 4 minus 2. So that's 180 times 2, giving me a total of 360 degrees. So the second part, add up what I know. So x plus 115 plus 80 plus 90 equals the 360. Remember, this right angle here means 90 degrees. Add up the angles we know. So that is positive 285 And for my final step, subtract from the total. So 360 minus 285. My missing angle is 75 degrees. Go back, rewatch this as many times as you need, and work some of these problems over again from the beginning to make sure you're understanding the flow of these type of problems.